Good afternoon, guys. I just want to summarize the important things that we need to understand when you are dealing with steam turbines. It can be both for Power 5 or Power Machines N6. So the most important thing every time when you are dealing with a turbine is to have this in your mindset. This is the most important thing that you must remember. If you can have a structure like this in your mind, it helps you to be able to draw your diagram easily. Okay. So basically, that's a rough sketch which you need when you are dealing with a steam turbine. Yeah, so we need something like this. So where our U, this is our U or our B. So we know that our U, that's our blade speed or our blade velocity. So that's our U, which is our blade speed. That is the speed at which your turbine will be rotating. So that's our blade speed. And then here we have our alpha 1. And then here we have our beta exit. And then we have our beta inlet. But remember, books, they are written in a different way. They might use different symbols. And then here we have our alpha inlet for the second stage. This one, I can make it our alpha exit. And then here we have our beta exit, but for the second stage, our beta inlet for the second stage. And then here, this one we can just leave it as our discharge angle or our turbine angle. So which you can say it's alpha exit, but for the second stage. So alpha exit for the inlet first stage. So the other thing that you must need to remember, it's our lines V1, where V1 it's our nozzle velocity. And then our VR1, that's our relative inlet velocity. And then we have our VFI, which is our inlet flow velocity or our flow inlet velocity. And then we have our VR2, which is our relative exit velocity. Remember, the ones that I'm referring to as a relative inlet is also referred to as the moving blade at which side? At inlet. This one is also our moving blade at exit or at outlet. And then this angle, which is also very important, it is the part of our fixed blade angle. At which side? At inlet. So in other words, our blade is fixed at this point at the inlet. So the name of this one becomes our fixed blade speed. At which side? At inlet. What else is key here? And then we measure from this point to this point. That is where we have our wheel velocity. That's our wheel velocity, which is measured from the end of the exit and the end of the inlet lines. And then we come to the second part. The names are more similar because we have our VR1, but this is for the second stage. We have our V1, but this is for the second stage. And then we have our VR2. This one, once again, is also for the second stage. And then we have our V2. This is also for the second stage. Remember, this is our V2, but this is for the first stage. And lastly, we have our wheel velocity for the second stage, which you can say just W. And then we also have our relative inlet for the second stage, and then we have our relative exit for the second stage. So most of the names of these lines on the first stage and second stage are similar, but there are a few things which I need to highlight, which you must not forget. Do not forget that this angle alpha E for the second stage, it's our fixed blade angle at exit. Do not forget that one. Many people, you'll be given in the exam, the question is saying the fixed blade angle at exit or the exit fixed blade angle is this one. And then you draw your diagram incorrectly. So you must remember this at this point, our turbine is fixed at an exit angle of the blades. So don't forget our fixed blade at inlet, our fixed blade at exit, and our turbine, a two-stage turbine, discharges at this point. That is where it discharges. And then let's look at a few things that we need to know. They will say to you there is no axial thrust, so we can say, they might say no axial thrust in the first stage. So what does it mean when they say there's no axial thrust, or there's no thrust? They might even just say there's no thrust in the first stage. What are they implying when they say there's no thrust in the first stage? Whether they say there's no axial thrust in the first stage. So when there's no thrust in the first stage, what it simply means that if you measure this line from this point to this point, if you measure from here to this point, you get 5 centimeters. Even if you measure from here to this point, you must get 5 centimeters, because formula for thrust says that thrust equals to M into V F1 minus our V F2. In other words, our thrust, it is the difference between our inlet flow velocity and the exit flow velocity. So because they are saying there is no axial thrust, if this is 5 centimeters, this is 5 centimeters, therefore your thrust is going to be 0 Newton. In other words, the force acting between the inlet and the outlet, it must give you 0, because they are saying there is no thrust, which is to say, if I measure this line, it gives me 5 centimeters. This line must also give me 5 centimeters. That is what is meant by there is no thrust in the first stage. So the same sentiment applies even if they say there is no axial thrust throughout the two stages. It simply means that if you measure here, you get 5 centimeters. If you measure here, you get 5 centimeters. And then you come to the second one. You measure here from here to this point, maybe you get 2 centimeters. You come here, it must also be 2 centimeters, because the lines on the second stage for your flow velocities, they must be equal. And then these ones must also be equal. We might assume that if this one is 5 centimeters, this one VF2 must also be 5 centimeters. If this VF inlet for the second stage is 3 centimeters, surely even this one should be 3 centimeters. That is what is meant by there is no axial thrust in the 2 stages, because the overall formula for thrust now becomes thrust equals to M into VF1 minus VF2 plus VF1 minus VF2. Don't forget, this is for the first stage, this is for the second stage. So this is for first stage and this is for the second stage. So if there's no thrust throughout the system or throughout the both stages, you get your answer as what? 0. Perfect. Don't say the question is saying there's no axial thrust in the first stage, and then you measure here, you get 5 centimeters. When you measure this line, you get 6 centimeters. Therefore, it shows that you are really dying, or you're having serious challenges. Now, the second aspect which we need to look into is this one. When they say symmetrical blading, so symmetrical blading, usually in the exam they can say there is a symmetrical blading throughout the 2 stages. So if there's symmetrical blading throughout the 2 stages, it simply means that B inlet equals to B exit. For which stage? A first stage. And also B inlet is equal to B exit for a second stage. This is what is meant by symmetrical blading across the 2 stages. It means that if you measure this angle, you get 20. This man must be 20, so that it really identifies that there is a symmetrical blading. So same applies to this one. If you measure this and this one, they must give you the same angles. If they say there is symmetrical blading throughout the 2 stages, but if they are specifying that there is symmetrical blading in the first stage, it only means that is this side. These angles must be the same. Or if they say symmetrical blading only occurs on the second stage, so you must know that these 2 angles are similar. So another term for symmetrical blading, they can say the angles are equiangular, or the blading is identical. So they can use the word the blading is identical, or identical blading. They just use some of those jargons to confuse you. So blading is identical, is the same thing as symmetrical blading. In other words, the blading is forming part of what? Of twins. That's what it simply means. And then another important aspect which you need to look at, axially discharge. Axially discharge, it simply means that our discharge angle, which is this one, forms an angle of 90 degrees. Yeah, so basically these are a few things that you need to remember, and you must also remember the formulas for the first stage. Don't forget these formulas. VR2 equals to VR1 times our K, where our VR2, that's our relative exit velocity, our VR1, our relative inlet velocity, our K, our velocity coefficient of friction. The other formula which is also important, on this stage is this one. 2V1 equals to V2 times our K. So basically, these are some of the formulas which we need to remember. The other formulas for calculating thrust, I've already given you here. Formula for calculating power, power equals to mass times our U times our W1 plus our W2. So you need to add your wheel velocity for the first stage plus the wheel velocity of the second stage. And the formula for calculating our blading efficiency. Efficiency equals to 2U times W total over our V1 squared. Then you get your blading efficiency. So this is a very simple topic. So for those of you who might be having challenges, please, you must ask questions on our YouTube channel, or you can ask on our page. Our page, the name is Engineering Hub. So thank you so much. We'll meet you on the second session.